Okay, so first we're going to review here some log stuff for the quiz. And let's start with number one. And I'll take, how about this? I will take volunteers. This is like the third time we've done this. So who thinks they know what log base 4 of 64 is? What do you have? 3. I'm seeing 3 in the chat. Nice. Okay, so the answer should be 3. That is correct. And the reason why, which you don't have to write, but just so in case people were confused, because that's the exponent that goes on 4 that will give you what's inside the parentheses, which is 64. Okay. The only thing you need to write though for your answer is the 3. All right, log base 25 of 5. All right, how about throwing that in the chat? What do you guys think? Okay. Definitely seeing a lot of halves. Yes. Good correction there, McKenna. Okay, so this is 1/2. That is correct. And the reason why, because 25 to the 1/2 power is 5. That's the square root. Okay. It's the exponent that goes on 25 that will give you 5, which is just the definition. All right, C was a little more challenging. Let's see if you guys got it. Oh, I couldn't fool you. Okay, correct, -3/2. So 9 to the -3/2, let's just work that out. That's going to be 1 over 9 to the 3/2. We kind of done this before, which is 1 over the square root of 9 cubed, which is 1 over 3 cubed, which is 1 over 27. So that is the exponent we are looking for, -3/2. Any questions on that one? That one was the toughest one on the warm-up for these. All right, now log. I did not write in the base, so it's understood to be what base? 10, yes. So no base written means it's base 10. And so 10 to what power will give us 0.01? -2. Nicely done. So 10 to the -2 is 1 over 10 squared, which is 1 over 100, which is 0.01. Here's the y, okay? But the answer is -2. Any questions on those? So on that, if you want more practice with that, on that review sheet posted on Canvas, there's a whole bunch with an answer key. Okay, there's a whole bunch of these. So if you want extra practice, make sure you spend some time, give yourself half an hour or so today to work on that. All right, number 2, we're using the log properties to figure these out. So I have log using 11 and 2. Now, did anybody come up with a way to rewrite 55 that would be helpful? That is right. 11 and 5 is what I'm seeing in the chat. Nicely done. So let's write this as log base 5 of 5 times 11. And then we use the product property, split that up. So log base 5 of 5 plus log base 5 of 11. Now, I'm not given log base 5 of 5, but we do know that, okay? 5 to the first power is 5. What's that? Or were you saying it?
Yeah, I was saying it. My bad.
I know, it's okay. Thank you. It's so awkward on this Zoom thing, and I had to be so careful about asking direct questions and pausing. All right, so yes, Aurelia is correct. It's 1. And then, oops, someone's calling me. Leave me alone. And then log base 5 of 11 is 1.49. So this is plus 1.49. So here we go. It's 2.49. How many people got that? How about giving me a thumbs up if you got that? Let me see where you guys are at. Okay. Also, many more of these to practice on that practice review. Okay. All right. Number, B. B is pretty straightforward, right, guys? Look, we have 11 over 2. That's what we have to work with. This is the quotient rule. So this is log base 5 of 11 minus log base 5 of 2. And I just realized I forgot to do something yesterday. Sorry. That's going to be 1.49 minus 0.43. And yeah, you guys got it. So this is 601, 1.06. Nice job. All right, now what about C? How can we rewrite 16 using either 11 or 2? Any ideas? Yeah, Jenya, Sydney, nice job. 2 to the 4th, beautiful. So I can rewrite this as log base 5 of 2 to the 4th power, which is equal to 16. Remember, you cannot add to the number. You can't multiply in by something. You literally have to just, it's like a transformation. Like think about a transformer, okay? You don't, I don't know, maybe they do add to each other, but it has to change forms without changing the number, okay? So rewriting 16 as 2 to the 4th is fine because you didn't add or multiply anything in or out. So then we use the power rule, bring down that 4. And now I have something that we're given, and it's 4 times 0.43, which is, I gotta do a little bit of work. 1.72. Yes, I see that in the chat. Nice work. Okay. Any questions? This seems pretty good. You guys are feeling good about that. All right. Chapter 11 is an introduction to trig. Okay. It's a fairly gentle introduction. So when you go on to pre-calc, which I think most of you are doing 1800, you'll do more rigorous trigonometry. So the first thing we have to do is get really comfortable. Actually, before I dive in, I want to do some calculations with you guys. Okay. So this is some prior knowledge that will be helpful, that I don't want to go over. I don't know. I've never taught it like this, but let's see how it works. We have to get, so the thing about trig is you have this unit of measure called radians. So you have radians, and then you also have degrees. So angles are measured in something called radians and degrees. And just so you know, the conversion there is 1 degree is the same as 180 divided by pi. I'm sorry, that's not right. 360 divided by pi. Now I wasn't ready to say that. I'll make sure I say the right thing. Give me 1 minute. Oh, okay, this is what I want to say. 180 degrees is equal to pi radians. Okay, so half of, so anyhow, let's leave that alone for a second. What I want to do is just some calculations using pi. Yes, okay, I know what I meant to say, but that's fine. All right, let's look at the number pi. We're going to have to be able to use estimates for pi. So everybody knows that pi is approximately 3.14. Okay, so there will be times where we have to be able to make that we have to know that. Okay, I'm thinking that that's drilled into your head by now, but if not, drill it in. Okay. The other thing we want to be able to do is figure out what multiples of pi are. So like 2 pi is 2 times 3.14, which if you multiply this, it's 6.28. And all I'm doing there is just multiplying decimals, 8, 2, 6, 2 places, okay? Yes, Nija, thank you for letting me know. And then we have, so you can multiply by 2 and you can divide by 2. Okay, so I want to be able to do this too. I want to be able to do 2 into 3.14. So that just goes in one time. Subtract, I get 1, 11. 2 goes in 4 times, 5 times. And that's 10. And I get 14. And this is 7. Okay, so pi divided by 2 is basically 3.14 divided by 2, which is approximately 1.57. Okay. Are you guys with me so far? So these are like boring little calculations, but we're going to use these numbers over and over. Now, the other way, the other thing is I want to be able to take pi over 2 and multiply that by numbers, like 3 pi over 2. That's going to be a big one that we use. So this is the same. If I take pi over 2, that's the same as 3 pi over 2. And when I approximate that, that's 3 times about 1.57. So that calculation is 1.57 times 3, 1, 2, 15, 16, 17, 4.71. So I want you to see where I got these from, because I'm going to use them interchangeably. So just to sum it up, pi is approximately 3.14. 2 pi is approximately 6.28. Pi over 2 is approximately 1.57. And then 3 pi over 2 is approximately 4.71. All right. Okay. So I don't know why I left this big space here, but I want to start over here. Let's do something. This is something called the unit circle. Okay.
The good old unit circle.
Yes. You do use pi to calculate circumference. That's right, Sydney. The good old unit circle. So this is a huge, trig functions are based on the unit circle. So we have to get to know it pretty well. And again, we're going to do a gentle introduction to the unit circle. When you get into pre-calc, you'll do a lot more with it. Okay. So here's a definition. The unit circle is the circle whose center is 0, 0. So it's centered at the origin, with radius equal to 1. So here's our equation. Since we just did circles yesterday, that equation would look like x squared plus y squared equal to 1. Okay, this is like the most basic circle, most important one, so we call it the unit circle. Okay, so let me actually, what's nice here is that I can use these drawing tools. Okay, and because my own drawing of circles is a little dicey sometimes. There we go. So here we have, this is the x-axis, this is the y-axis. And since the radius is 1, that means that these 4 points are just 1 unit from the center. So this is the point 1, 0. This is the point 0, 1. This is -1, 0. And this is 0, -1. And that's standard. You got to know that those points should be like this. I mean, they're just on the axes, right? Now, here's the thing. Remember when I said earlier that 180 degrees is pi radians, which we're going to talk more about that in detail later. Okay. That means that if you, most of you are familiar with angles enough to realize that if I were to go around the circle, this is 180 degrees, right? So our first measurement on the unit circle is that this is pi radians. And we don't usually write radians because like degrees, you have that nice little circle. It's easy. Radians is a word and it's going to muck up my picture. Okay. So that's pi radians. Now, if I kept going, this would be around my circle. This is a whole nother pi radians. So if when you navigate the unit circle, you're going around the edge, okay? So we're going to talk about going around the edge, and then we're going to look at the angles later on, okay? So I'm walking around this circle. The first round is to pi, and then if I go the same distance twice, then by the time I get here, this is 2 pi, okay? So the distance around the unit circle is 2 pi radians, which kind of makes sense when you think about it. 2 times 180 is 360, okay? And if you have any familiarity with geometry, 360 means you just go in a circle, right? So 360 is 2 pi, all right? The way I want you to think about this is kind of like a circular track, okay? I hope everybody's had the opportunity, maybe fortunately or unfortunately, to go around a track, like at your high school or gym or something, and there's a measurement, okay? So 4 times around a track is a mile. Everybody familiar with that? 1 time around this track is 2 pi, okay? That's our distance. So we're gonna be walking around the unit circle. So when walking, I'm just going to use walking as it's just easy to talk about, okay? Or when moving, when, you know, whatever, when navigating, when walking around the unit circle, we always start at 1, 0, okay? We always start there. And go counterclockwise. Okay, so let me fill in a couple more things on our unit circle that's going to be important stops. So I already mentioned this one. If I start there, that's 0. Okay. Now, when I arrive at this point here, do you guys see how that's half of the top part of the circle? Well, if the distance from 0 to pi is that first half, then if I stop halfway, that's pi over 2.
Pi over 2.
Yeah, that's halfway to pi, so it's pi over 2. Okay. Then once I get to pi, so I'm traveling to pi over 2, then I get to pi, and this distance here is another pi over 2 distance. So this part right here is going to be pi plus pi over 2. Just put this down here. Okay, if I'm looking at the distance, I go pi units and then pi over 2 more. Well, that's going to be 2 pi over 2 if I get a common denominator, which is 3 pi over 2. So this is 3 pi over 2. And we could count it. You can see it actually. If I go 1 pi over 2, 2 pi over 2, 3 pi over 2. And then when you come back all the way around, this is 4 pi over 2, which is just your 2 pi. Okay, do you guys see how to count that? Pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, all the way around. Okay, now this is why it was important to know these numbers too. Because these are the points you know on your unit circle definitively. But if I want to estimate this in terms of a number, pi over 2 is just a number. So that one is about, we said 1.57. We know that pi is approximately 3.14. And this we said was about 4.71. And then 2 pi is approximately 6.28. So these are the same. Okay. Now this is what you have to have memorized. You have to know this. You don't want to, like this, you should be able to recreate like in your sleep. Okay. I got my circle. I got my points, my 4 points. I know this is pi over 2 pi, 3 pi over 2, 2 pi, and I know approximately what those are. If you can memorize that and you have that down, the rest of this is going to flow easily. But if you have to stop and think about it every single time, everything's going to take much longer. Okay. All right. So let's practice walking around the circle. So I'm going to come down here. So walk again, walk around the circle, around the unit circle. I think these are all miles, the given distances below. Okay, so I'm going to need a new circle. You're also going to be drawing a lot of circles. Oh boy, it's going to be a difficult one. Okay. X, Y. So here's my points. And I'm just going to put on there, let's put 1, 0, 0, 1, which is pi over 2. And then I have -1, 0, which is pi. And then 3 pi over 2, which is 0, comma, -1. And then 2 pi. Okay. All right. So A. Let's go pi miles. Find or estimate the coordinate pair the coordinate pair walking blank. Okay, so here's A, pi miles. And I'm using the word miles. They're not really miles. In that case, maybe radians would be the thing, but just to keep it, not get too technical, okay? Because all we're doing is trying to walk around the circle to that point and then tell me what the coordinates are. So this one's pretty straightforward, not too bad. If I start here, you always start at 1, 0. I'm going to walk around the circle, the edge, until I get to pi. And that is an exact pair of points. That's going to be -1, 0. Is everybody okay with that? That's exact. Now, let's do one that's maybe not so exact. Let's go 3 miles. Again, miles, because we're kind of thinking about it like a track. Again, you always start at that point 1, 0, and I'm going to walk all the way to 3 miles. Now, here's where your estimates are really important. Okay, so let me pause here. This, if I walk from here to here, this is about 1.57 miles. Everybody see that? Now, if I go all the way to pi, this is about 3.14 miles. That's too far. Okay, so to go 3 miles on my unit circle, I need to actually stop. Maybe like right here. Everybody see that? Not going to quite go all the way to 3.14 because I want to go only 3 miles. Now, that means that this point that exists there, I have to estimate those coordinates. They are not exact. I'm not going to make it to like -1, 0. I have to use some decimals here. Okay, so if you look at the x coordinate, if I go like, if I'm trying to get to this coordinate, you know, usually you go along the x-axis and then up to the point. Well, that's really, 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 really close to -1, isn't it? So I'm going to estimate my x coordinate to be about -0.95. It's more than 0.9. Okay, that is super, maybe even, you know what? Maybe even -0.99, because that is really, really, really close to -1. Okay, but it's not -1. We don't quite make it to -1. Okay, now what about the y coordinate? So you have to realize that this distance on the y-axis, this is 1 unit. So how far up do I need to get to that? Give me a decimal approximation of how far up you think you have to go. 0.1. Yeah, that's pretty good. Okay, so my coordinates here are going to be about, these are approximations, -0.99 and 0.1. And that's the best we can do for right now. Or 0.15. I would even say 0.2. But definitely very close in that range. So these also are approximations. The better you draw the circle, the better you get an approximation. So sometimes when I'm teaching this in class, it doesn't even look this good because my circles on a whiteboard are not as good as these. Okay. All right, let's do part C. So I guess this would be one good reason for using something like this. Let's go 5 miles. Okay. I'm going to try to keep the same circle, so I have to keep redrawing it. Let me try to use purple. Okay, so again, we always start at the beginning, and I'm going to sweep out. You guys tell me when I should stop. You can either put it in the chat, so be ready to go, or you know what? You can use your reaction. How about an oh no face? Or something. Tell me something. Tell me where to stop. So I hope you can see it. Can you guys see it? Oops, I went off the circle. Now you can see it. Tell me where I should go to get to 5. Whoop, I went off my circle because I was looking at the thing. Oh, nobody's paying attention. Or you're not sure. Oh, McKenna, I'm sorry, you weren't on my immediate screen. Let me put you guys more people I can see. No, I don't want that. Side by side, side by side. Okay. So, all right. So let's make sure we understand. So here was 3.14. What was 3 pi over 2 approximately? 4.71. So when I arrived at this point, when I went around my circle and I arrived there, I had gone 4.71. That's not quite enough. If I go all the way to 2 pi, this is 6.28. That's too much. So it's going to be just past, maybe like here. Okay, this is my 5 mile mark. Maybe a little bit closer. Are you kidding me? Maybe it is just slightly closer, but okay, that's close enough because if I try to erase it, it's going to get messy. All right, so now let's estimate this point. What would be my x coordinate? I would have to go about this far, maybe a little bit less. I went a little too far there. I still did it again. What did you guys say it is? About what? What would be the x coordinate? Okay, so x is we have to go this direction. Now all the way out would be to 1. Yeah, about 0.5. Okay, it's halfway to 1. And then I have to go down. And then yes, that would be the y. The y would be about negative 0.9, negative 0.8, somewhere in there. So this is 0.5, negative 0.9. Okay, you guys see how we're estimating these? All right, let's do one like this. Where's my time? Okay, D. Let's go about 7 miles. Now, remember, it's like a track, so it's perfectly fine to loop around. Let's see, I'll try this color. Oh, all right. So if I start here, I'm going to go around. Here's 1.57 miles. Now I went 3.14 miles. Now I've gone about 4.71. And when I get all the way around 6.28, but that's not quite 7, I have to go a little bit past it. So I'm going to loop, and that's fine. So this point is going to be 1 revolution and a little bit more. 1 rotation. So then what's this point going to be about? Let's see. If I go this, here's x. X is about, let's say 0.8, 0.9, somewhere in there. What about y? About
0.2, 0.3 maybe?
Yeah, if I look at where I drew it, I'm going to say about 0.4, according to my picture. 0.35, yes, Amaria, even more precise. Now, here's the thing. Most of the time, you guys are going to be drawing your own circles. The circles, depending on how good you get it, if it looks more like an oval or whatever, your approximations may vary a little bit between each other, okay? Because your homework tonight, or actually, this is the homework, I think, for tomorrow. Maybe it is tonight. Did I assign 11.1 tonight? I don't remember. But when you do this on your homework, just make sure that the circle that you draw and you show the point where you stop, that your approximation is based upon that. If you match those up pretty good, I'm going to give you, you're going to get pretty good credit there. Okay. All right. Let's do a couple exact ones and then I'm going to move on. Let's do, here. How about 5 pi miles? Okay. To go 5 pi miles, let's see, I'm running out of colors. Ooh, let's do the rainbow one. Okay. To go 5 pi miles, again, I'm going to start here. Okay. And I keep going. Oops. Here is 1 time around is 2 pi. Okay, that's not enough. I go around another time, this is 3 pi. Then I go around again, here's 4 pi. And then it's going to take 1 more halfway, this is 5 pi. So to get to 5 pi, you have to go around twice and then another half. Okay, so I finally have gone 5 pi over 2 miles. I'm at this point. What is it? -1, 0. That's right. Okay, that's an exact one. We don't need to estimate that because it's exactly at a measured point on the circle.
So all of the pi miles will probably, well, depending on what the pi mile is, it'll probably be one of the points we already have. But all the ones where we're trying to get estimated miles, it'll be like estimated points.
Yes.
Okay.
Yes. Aurelie, do you have a question? Do you have your hand raised? Or is that just part of your name? There's like a little hand next to your name on your. Oh, okay. All right. All right, let's go over here. So yes, Cornelius, you're right. Usually with pi's involved, you're going to get an exact point. Let's do one like this, 5 pi over 2. All right, now my circle's getting really messy, so you guys have to bear with me. You know what? Let's do a different one for that. And I'm just going to draw it because I'm running out of time. So here's F, 5 pi over 2. So I'll show you guys how I really do this. That's actually not bad. I will tell you this. Here's a little hack. Draw the circle first, then the axes. If you draw the axes first and you try to center the circle, it never goes well. It's always off. So draw your circle and then cut it in half with your axes. All right, so I'm going to start here, and I want to go 5 pi over 2. So here, let me show you counting for this one. Here's pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. Each one of these quarters is pi over 2. So you guys see how I measured? 1, 2, 3, 4, and then back here is 5 pi over 2. So we end up back at pi over 2. So that's the point 0, 1. That's the stop. Any questions? Okay. Now, the other thing is that you can go negative units on your circle. So say we want to go negative pi miles. So here's my circle. Okay. All this means is negative means reverse direction. Go clockwise. Okay, so I still start at the same place, but now instead of going this up, I'm going to go down. So I'm going to go I'm going to go this way. So this is the point -1, 0. It's not too exciting, but let's do so anyhow, you'll get a few of those thrown in there. That's more of a bigger deal as we go higher in math. All right. Last one for today, I think. Let's go 23 pi miles. Now, you can circle that as many times as you want, okay? But let's think about this. If I go around one whole time, how many miles is this? It's 2 pi, right? So how many times would I have to go? I'd have to go 2, 4, 6, 8, 10, 12. I'm not even close to 23. What number would be closest? If I go around so many times? 11 times would give me 22 pi miles. Okay, you guys see that? If I go around 11 times, go around my track 11 times, that's 22 pi miles. And then if I go one more, that's here. So this is pi, which is the same as 23 pi. So this would be also at -1, 0. Okay, so if you get ones like that, make sure you stop and think. I mean, you can count if you want to, but each rotation is 2 pi. Okay, tomorrow we are going to do, we're going to look at sine, cosine, and tangent on the unit circle. And so that should be kind of fun. Okay. Office hours at 11:30. If you want to come ask anything, I will be there.
Thank
Thanks,
you.